In this demo, we'll use a function-based index to create an index over a subset of the rows in the applications table. Namely, those rows that have an application status of either in or p, representing new or in-process applications. To get started, I want to create a traditional B-tree index on the application status column, and to do so, I'll just use the standard syntax. Now that this index is created, let's look at the size of this index, and we can do so with this query. Okay, we see that this index is taking 256 blocks, and this is taking up about 2 megabytes in disk space. We also see that each key on average takes up 41 leaf blocks, and of course, this average value reflects those 2 keys that are associated with almost all of the rows in the table. What is driving all of this is the fact that the index is over all of the rows in the table, not just the rows of interest, which of course are a small fraction of the rows. Now we can run a query against this table, and we see that this index does indeed work. The index is getting used, and the index operation has a cost of 3. The real problem here, though, is that we're indexing a bunch of rows that we really don't care about. So let's try out our function-based index. So first, we'll drop our existing index. And now we'll create the function-based index. And again, let's get some information about this index. So we see right away this index is significantly smaller. It's taking up just 8 blocks and it's just 64K on disk. So this is a significant improvement than what we had before. One can imagine that if you had a larger table, these savings would be even more significant. Our table here only has 90,000 rows in it. Now let's execute the query from the slides to see that this query does indeed use our function-based index. And we see indeed that it does. Oracle's using the function-based index and the cost is only 1, so it's slightly less expensive. But the big benefit here is that now on one of these low cardinality columns, we have the ability to index only the rows that we want, that small fraction of rows. So this keeps our index nice and small. In this case, the full-size index was just 2 megs, but this is because there's only about 90,000 records in the applications table. If you have a very large table that tracks orders in your organization or something like that, and that table contains several million rows, as you can imagine, the savings would be much larger from using a function-based index in this way to track only that small subset of rows that you care about.